Hello, I am Olalla, a student at UPF, and this year I am finishing biomedical engineering, but first I will have to present my bachelor thesis, which is titled Endoscopic Vision Challenge for Surgeon Action Detection. I hope you will understand it at the end of the video. This thesis is based on a project called SARAS, that stands for Smart Autonomous Robotic Assistant Surgeon. The goal of the project is to allow a single surgeon to execute robotic minimally invasive surgery without the need of the assistant surgeon, and this would, of course, imply a lot of social and economic benefits. Having this goal in mind, the final product of Sarah's project will be building a pair of cooperating and autonomous robotic arms that they will be called solo surgery. Sarah's project is a big organization that at the same time is divided into small sub-projects, and my thesis is focused on one of these small sub-projects that is called the SARAS ESAD Challenge. That is, the ESAD part stands for Endoscopic Surgeon Action Detection, as the title of my thesis. So these words are because the goal of the challenge is to detect the surgical actions of the surgeon that is using the Da Vinci robot to perform the surgery. And the endoscopic part is because all the material in the dataset are recorded with an endoscope that has a camera attached to it. The best way to understand this challenge is to look at the dataset that is formed by thousands of these type of images, and altogether they form 4 complete prostatectomy surgeries. A prostatectomy is removing the prostate from patients, from male patients. So in these images, we can see they usually have from 0 to 2 surgical actions. For example, here we see the action of cutting the mesocolon and pulling tissue. And a characteristic that this dataset has is that all the actions are surrounded by these red bounding boxes. So this helps the algorithm to identify and localize the actions of the Da Vinci robot, so that later the algorithm can make a decision on how to help, maybe holding an instrument or maybe cutting some thread. How am I gonna achieve this? The methodology that I will follow will be, first, I will try to reproduce the baseline model that Sarah's project per se offers, and it is a RetinaNet, but I won't enter into machine learning details. And then I will try to get some useful ideas from the teams that ended in the top 4 positions, like mixing the baseline model with these ideas and some ideas that I may have. For example, I will of course for sure perform data augmentation, because there is not enough data, there is not a balanced number of surgical actions, and also I will perform that data hyperparameterization. Summing up, the goal of my thesis is to improve the algorithm on identification and localization of surgical tasks, and then implement this algorithm into the solo surgery robot, becoming one of the next generation's surgical robotic systems. So that's it. Thank you for listening. I hope you understood it, and bye.